Welcome to today's video. Today we're going to be focusing on determining direct variation. We're going to be given an equation, table, set of ordered pairs, or a graph. We're going to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have the notes page in front of you. If you don't, take out a separate sheet of paper and we'll get you a fresh copy tomorrow. Now, a direct variation is a specific relationship in which there is a constant ratio, and that ratio needs to be y over x, and it has to be between all the ordered pairs. It is always the ratio of y over x. Now, my y over x is what we're going to call k. K is equal to that constant. So whatever that ratio is, if it says find the constant, it's going to be our variable k, and that's just going to be your ratio of y over x. Now, our equation for direct variation, well, if I take k and we use literal equations, we always want our equations in y equals. I'm going to multiply both sides by x. I get y equals kx. So that is my equation. It looks similar to slope-intercept form. The only difference is we don't have an intercept. Our intercept is 0. The one thing that you need to keep in mind with direct variation, it needs to go through the origin. Every direct variation goes through the origin. And we know this because there is no y-intercept on our equation, so it's 0. Well, the point 0, 0 is an ordered pair, so it needs to go through that origin. Now, if we look, we want to start by finding our constant k. It is always, always, always going to be y over x. So here, I have 4 over 1. Well, that equals 4. I have 8 over 2, that equals 4. I have 12 over 3, that equals 4. And I have 16 over 4, that equals 4. Because all those numbers are exactly the same when we divide them, that is my k value. K is going to equal 4. My equation would be 4x. If I look at number 2, again, k for my constant is always y over x. So 3 over negative 6, which is negative 1/2. 2 over negative 4, which is negative 1/2. 0, 0 is the origin, so that automatically works. And then I have negative 1/2. Because all three of those are the same and it goes through the origin, it's a direct variation where my value of k is negative 1/2. So my equation becomes y equals negative 1/2 x. If we look at number 3, again, y over x. It's just written as a table, but we can still do y over x. I have negative 8 over negative 12, which simplifies to 2/3. I have negative 4 over negative 6, which simplifies to 2/3. 0, 0 is the origin, and I have 2/3. Well, if I look, all my constants are the same, and it goes through the origin. So that means my k is 2/3. And my equation is y equals 2/3 x. Your k is what you get when you divide. And be careful, it has to be y over x. Think about slope. Slope was always y over x, so my k, my constant, is going to be y over x. Number 4, again, I'm still going to do it. Y over x. 12 over negative 4 is negative 3. 3 over negative 1 is negative 3. Negative 9 over 3 is negative 3. And negative 15 over 5 is negative 3. All four values are the same. So k equals negative 3 and y equals negative 3x. It's important to be able to find that constant. And you have to keep in mind it is always going to be y over x. Now, if we look at identifying some equations, we're not going to do all of them, but if we go through, you have to keep in mind your equation, we have two. We have k equals y over x, and we have y equals kx. Those are the two different types of equations for direct variation, and those are the only two that we can have. So if I look at number 5, I have y equals 3x. Well, in this case, 3 is my k, so yes, this is a direct variation. If I look at number 7, I have y equals 2. Well, if we notice, in my original equation, this is y equals kx. There is no x, so this is not a direct variation. If we look at something like number 9, we have x minus 4. Well, that minus 4, if we look at our direct variation, nowhere do we add and subtract. So since we are subtracting, this is not a direct variation. It is a linear equation, but it's not a direct variation. If we look at number 11, well, I don't have it in either form. I don't have k equals or I have y equals. So I'm going to solve it for y equals. If I solve it for y, I'm going to divide both sides by 2. Well, y equals 1 over 2x, because technically there's a 1 in front of that x. So now if I look, now I'm in the form y equals kx, where 1/2 is my k. So yes, this is a direct variation. Because I just have a slope in my linear equation, it makes it a direct variation. If I look at number 13, again, we have to solve for x, or for y. So I'm going to subtract 5x on both sides. I'm left with y equals negative 5x. I'm not going to put the 0. We don't have to put plus 0. Now I'm in the form y equals kx, and my value of k is negative 5. So yes, this is a direct variation. Try the other 5 on your own. The answers are posted. You can check yourself on them. Now, when it comes to a graph, it's the same thing we've been doing, but we need to check for 2 things. First, does it go through the origin? If it does not go through the origin, it is not a direct variation. And the second thing we need to check is for a constant ratio, and that ratio is y over x. So, if I look at number 14, number 1, the origin, does it go through the origin? Yes, it does. So now we have to check. If I go from my origin to my top point, I went up 3 and I went over 2. If I go from my bottom point to the origin, I go up 3 and I go over 2. So does it have that ratio? Well, if you notice, both points follow the same. My ratio is 3 over 2. If you can find the slope of the line, and it is a constant slope, and it is the same slope each time, then yes, it is a direct variation. If we look at number 15, first thing you have to ask yourself, does it go through the origin? No, so it is not a direct variation. You can stop right there. If we look at 16, does it go through the origin? Yes. The second thing you have to look at is the constant ratio. I went down 1, positive 4, down 1, positive 4. So since it follows the same pattern, it has that constant ratio, my k is going to be negative 1/4. For 17, again, does it go through the origin? Yes, it does. Number 2, I need to find my ratio. Well, if I look, I went up 3 and over 3. Now, there isn't another point, but you can still check yourself. If I go up 3 and over 3, does it still work? Well, yes, it does. And in this case, we're going to simplify my k. K is going to equal 1. You always want your k, just like when we were doing slope, you always want it in simplest form. Now, the last type of problems with direct variation is finding those missing values. And it's fairly simple, but the big thing you have to keep in mind when you're doing a direct variation, your k is going to equal y over x. And think, direct, we're dividing. So if I'm doing y over x, well, I'm going to set up 2 proportions. I have negative 4 over 2, and I'm going to set that equal to y over negative 6. Because when we did it earlier, to figure out if it was, we had to divide both of them. They have to equal the same number. So now we can set them equal to each other, and we can solve this. Use cross multiplication. We get 2y equals 24. Divide both sides by 2, and y is going to equal 12. And you can check yourself by writing out my 2 points. If I do negative 4 over 2, well, that equals negative 2. If I put 12 in for y here, it becomes 12 over negative 6, which equals negative 2. Those two equal each other, so we know our answer is correct. If we look at number 20, again, we're solving for that, and it's a direct variation, so we want to divide for our ratio. I'm going to do y over 12 is equal to 7 over 4. It always, always, always has to be y over x. So I'm going to cross multiply. In this case, I get 84 equals 4y. I'm going to divide by 4 on both sides, so y is going to equal 21. And again, we just want to check ourselves. If I do 21 divided by 12, that reduces to 7 over 4. They are both the same, so we know our answer's correct. Now, when it comes to word problems, please make sure you're careful on what you pair with what. It says, if y equals negative 18, then x equals 3. Those two are grouped together, and those next two are grouped together. But make sure you read it carefully. So we still want it to be y over x. In this case, I'm going to have negative 18 over 3. I need to find x when y is equal to 30. So we're still setting it up the same exact way. You just have to slow down and make sure you know which one's x and which one's y. From here, we're still cross multiplying. 90 equals negative 18x. We're going to divide both sides by negative 18. X is going to equal negative 5. And again, check yourself. We have negative 18 over 3, which equals negative 6. And then I have 30 over negative 5, which equals negative 6. They equal each other, so we know we're correct. If I look at 24, if y equals 10 when x equals negative 4, find y when x equals 12. So again, we still want y over x. It's going to be 10 over negative 4. We're finding y when x equals 12. So now we cross multiply. We get negative 4y equals 120. I'm going to divide both sides by negative 4. So y equals negative 30. And again, go back in and check yourself. If I have 10 over negative 4, well, that becomes 5 over negative 2. If I have negative 30 over 12, that becomes negative 5 over 2. They are the same number, so we know our answer was correct. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.